There you go. So, what have we? Okay, here. And now, this is chapter 3, selection control structure. Okay, last week we've covered about the
Sequence structure.
there you go. Now today, or starting this week, we're going to have a look at the selection. What is selection? You want to select. Yeah, you want to choose. So we have Boolean values, relational operators, logical operators, type of selection control structures. Quite a lot of things that they allocate 3 weeks for us to study about this. Although I strongly believe that we can go a bit faster, so we can do more. What is it? We can do uh, more practice on this topic. So Boolean value, I already explained to you the last time, only have two possible values, true and false. Yeah, true, either you write the term true, uh, so you can either write the term true, or you can also write 1. You can write the term false, or you can write the 0. So they mean the same thing. To declare a Boolean variable, you use the keyword bool. Bool is a data type. Yeah, similar to integer, uh, char, what else? Integer, char, we can also have float, double, those kind of things. Yeah, bool is also a data type. So bool b value equal true. Or if you want to write that into a single statement, we can have bool b value equal true. Okay, the same thing. This is called what? This is called declaration. And this is initialization. When converting integers to booleans, the integer 0 resolves to boolean false, whereas non-zero integers all resolve to true. Although personally, I never use all of that. I would personally prefer to stick to zeros and ones. Now, relational operators. What is a relational operator? We have, so in math, we have equal sign. In C++, it's double equal sign. Yeah, this is equal. In C++, it's double equal. Plain English is equal. Example, if A equal B, that's how you write it. If A equal B, not A equal B. Because this will be what? If you do something like this,
Will
this is
replace the
called,
value.
yes, and the term we call that in programming is assignment. Okay. We assign B into A. Okay, less than is fine, the same for math and C++. Less than or equal to, in C++ we have that. Apparently we do not have that symbol, and we have to resort for less than equal sign. Yeah, for less than or equal to, greater than are the same. That for greater than or equal to, not equal to is represented by that is not equal. This is not. Any question? No?
No.
Move along. Yeah, move along. Relational operators allow comparisons and requires two operands. Return 1 if expression is true, 0 otherwise. Comparing values of different data types may produce unpredictable results. For example, this is integer 8 less than character 5. Should not be done at all. Yeah, 8 is represented by the value of 8, whereas character 5 here, when it states that it's in a single quote, yeah, when it is in a single quote, this is a character. This is represented by ASCII. ASCII values, not the value, not the number 5 value. So when you want to perform the comparison, make sure they belong to the same data type. So 8 less than 15, the answer is true. That's what it will yield. 2.5 greater than or equal to 5.8. This will yield false. Exercise 6. That. What is the answer? True or false?
False.
False. Why? Because 6, the statement says 6 not equal to 6. Of course, this is false. 6 is 6. 5.9, that, and 7.5.
True.
True.
Yes, there you go. Easy. Yeah, this is easy. Logical operator. Now, let's have a look at logical operator. We have that symbol that is not. That is and. And that is or. Of course, you can find the ampersand. Yeah, of course, you can find the ampersand. Where is the pipe? Well, generally people call this line pipe. Where is the location of pipe on your keyboard?
Above enter key.
There you go, above enter key, in which you have to press shift, isn't it, to access that?
Yes.
So there you go. Right, move along. Now it's best to find out about it now, because generally most lecturers would expect people to find it on the keyboard, but this is not the character that we are familiar with, isn't it? Yeah, most of us will not be familiar with this pipe sign. So that's the reason why comma is to right. Comma. Hold on. What's the question? No, comma is not end.
No,
Comma is not end.
thank you,
Okay,
sir.
comma is not end. It has to be double ampersand. It has to be double ampersand. This is and, this is all. Now the truth table. How many of you do not know about the truth table? Raise your hand. I thought this has already been covered in high school.
Mathematics.
Yeah,
Yes.
isn't it? Yes.
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 Digits.
Now, why did you raise your hand then? Not covered in your syllabus, is it? Huh? Okay, let's have a look at the truth table. We have input. Input 1. Input 2. These are the operation. These are the operation. When P equal false, Q equal false. P and Q, false and false, will yield false. False or false will yield false. False, sorry, not P, not false is true. Not false is true. False and true equal false. False or false, sorry, false or true equal true. This is way too difficult, isn't it? False and false equal false. False and true equal false. True and true equal true. True and false equal false. This is for AND operation. This is for OR operation. False or false equal false. False or true equal true. True or true equal true. True or false equal true. That's what it says. Of course, not is easy. If it is false and you perform not, what is not false? Then it's true, isn't it? If it is true, what is not true? It's false. It's just flip. Yeah, basically just flip the answer. Any question on this part?
Nope.
No. No.
No? No question, then we can move along. The precedence operators. Yeah, we continue from what we've covered in the previous weeks. Of course, the top most priority is the one in brackets. Then we perform the unary operator. Then we perform the multiplicative operator. Then we perform the additive operator. Then we perform the relational ordering. Equality, logical AND, logical OR, then only the assignment. So this is the order of precedence from top to bottom. Yeah, from top to bottom. Which one has higher precedence? Of course, the top one will have higher precedence. Where is the question? Come on. Logical expression. Expression that can be thought of as being true or false. True if correct and false if not correct. The expression uses relational operators such as the equal sign, yeah, less than, and logical operators such as and, or, and not. Logical expressions can be unpredictable. The following expression appears to represent a comparison of 0, num equal 12 and 10. If 0 less than or equal to num less than or equal to 10, num is 12. Now, you want to perform two operation, two comparison in a single statement. It always evaluates true because that will be done first. Zero less than or equal to num. Num is 12. What does this statement yield? This will yield true, isn't it?
Yes. True.
True less than or equal to 10. That's 12. Less than or equal to 12. This is false. So it's because 0 and 1 is true. All right. It doesn't compare 12. It compares to 1 because true equal 1. 1 is less than or equal to 10. A correct way to write this expression is num greater than. All right. There you go. It's always best to separate. It is always best to separate the expression. If you have something like this, don't put two statements or comparison together. You separate them. You separate them and you perform the AND operation. Well, depending on the situation. Sometimes you may want to use AND, sometimes you may want to use OR. It's entirely up to you, whichever way that works for your program. Yeah. So in this case, num is greater than or equal to 0, which is true. Num is less than or equal to 10, which is false. True and false equal. True and false equal.
False.
False.
There you go. So, in your opinion, how do we go about with this example? We have 80 to 100. So, this is A, B, C, F. How do we go about doing this in C++ expression for the range between 80 and 100? Let's call this mark. How do we compare that to the range? Mark. Oh, instead of mark is a bit too long. M for mark. We want mark to fall between 80 and 100. And the statement will be true. How do we do that?
M is greater than or equal to 80.
Greater than equal to 80.
Then put operator AND.
Yep.
M is less than or equal to 100.
You get the picture? Class?
Yes.
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 Similarly, here. Now, what happens if the value is lower than 50? Right, we'll put it. Okay?
All right.
Okay.
What is it?
True.
True.
What is it?
False.
False.
What is it?
False.
True.
False.
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 Yeah.
All right. So let's go over the first one. The first one is fine. True or false equal true, which is correct.
Yes.
Now, in this case, what will happen? 3 and 5. 3 always result. Notice, this is where we have to go back to the order of precedence. First, do everything in parentheses. Perform unary operator. Then perform multiplicative. Perform addition. Perform relational ordering before we get to logical. All right, we have to perform relational ordering. That is true. That is false. True and false become false. Perform this one first because that takes higher precedence. That is 20. Less than 20 is false or false. Equal false. So this is correct. Get the picture?
Yes.
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 Easy?
Yes.
Easy.
Right. We have assumed x equals 5, y equals 6, and z equals 7. We have Boolean expression. What if we run whiteboard? Start a new whiteboard. Share with everyone to edit and send. Now let me choose. Any volunteer?
I volunteer for first one.
All right. Any other volunteer? You can start working on question 1. Any other volunteer?
Me.
All right. You can work on question number 2.
Okay.
Question number 3.
Me.
Okay. Mudiana, you can work on number 3. Number 4. Who is this? Can we ask Izzatul Alia to work on number 4? Yeah? Izzatul Alia? Izzatul Alia? Is she here? Izzatul Alia? Right, she's not here, perhaps. We call for Naufal.
Number 4.
Naufal? Yes, please.
4.
And yes, number 4.
Oh, okay.
And number 5, we call for another lady. Nur Eliani. Yeah, Nur Eliani.
Okay.
Okay, you work on number 5. You can choose separate board. It'll be easier. Yeah, you can choose separate board. And please write down the number as well. 1, 2, 3, or 4 or 5. So number 1, x equals 5, y equals 6, z equals 7. Now we have the Boolean expression is x less than y and z is greater than y. There you go. 5 is less than 6. By the way, if I may ask, let me just bring this over. It'll be easier. So you can see. So x equal less than y and z is greater than y. So 5 is less than 6 and 7 is greater than 7. 7 is greater than 6. The statement is true. The statement is true. True and true is true. So of course this is correct. Hold on. It's fine. So I need to use, hold on. It's my pen. And change the color. Correct. Question number 2, Boolean expression. X is less than or equal to z and x is greater than 0. 5 is less than or equal to 7. True. 5 is greater than 0. True. True and true is true. X is greater than or equal to y and z equal to 3. 5 is greater than or equal to 6. False. 7 equal to 3. False. Value equal false, and false is false. Never mind, we'll have a look at number 4 in a bit. X is greater than y or 5 is greater than 6 is false, or 7 is greater than 6 is true and not. 7 is less than or equal to 0. This is false and not false. So this is where we have to perform that one first. That bit. Not false is true. True and true is true. True or false is
True.
True.
true. So the answer is true. Understand?
Yes.
Yes, sir.
Yes.
Okay. So the order of precedence takes place when you have a full statement like this. First, you have to perform that. Then and come after before. Yeah, and you must solve for and first before you solve for or. That's why here unary operator not false is true. Then we perform true and true is true. True or false is true. So the value is true. Y less than 15, not y greater than. What is y? Y is 6. So 6 is less than 15 or not 6 is greater than 10. So that is, we get true or not false. So first we perform this bit, which is true. Not false is true. So true or true is
True.
true. That is the answer. You get the picture now?
Yes, dear.
Yes, sir.
Yes. Evaluate the following expression. There you go. Shall we ask someone to do this in Jamboard as well? Can we ask? Can we ask Rizwan, please?
Yes, sir.
Rizwan?
Yes.
Can we ask you to solve for this?
I'm not sure.
Not sure about what?
I'm trying.
Okay, my advice is to use the text box and put a bracket so that we can see which one to do first, such as this. For example, we want to do this. We change the color. That has to be done first. Hey, hold on. Can we? That has to be done first. Can we change the color? The text color. Oh no. Oh, it doesn't work that way. That has to be done first. That has to be done second. And of course, you have to solve for that. And then we have what will be 17 less than 4 multiplied by 3 is 12. 12 plus 5, put in bracket, or another bracket, 16 equal, oh, that has to be done first as well. 16, close the bracket, and not in bracket 3 equals, yeah, hold on, not 3, 6 equals 6. Put in the bracket. From here, we can perform. From here, we can perform the put it somewhere. Okay. From here, we can perform what? Here we perform that bit first. That is done. That is done. And this bit, maybe. Right? Which yield 17 less than 17. Or true and 6 equals 6 is true, not true is false. False. From here, we get the true, the real expression. 17 less than 17 is false. Or true and false. So we solve for n. First, we have false or true and false is false. So in the end, false or false will result in false. There you go. Have you any question?
No.
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 Is my answer correct?
Yes.
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 Just so you know, I have not attempted this question. So this is my first time attempting this. This is the reason why I'm asking you whether my answer is correct or not. But remember, when we're working on questions like this, always take into consideration the order of precedence. Now, evaluate the following logical expression. What is the answer?
The answer is false.
How do we do that? First, we have to solve for everything in the bracket. Inside here, we have one bracket. 3 not equal to 13. That becomes true. And now we have double bracket. So double bracket, we'll solve for this one first. Then this is a bracket. 3 is greater than 5.
False.
It's false. Or 13 is less than 10.
False.
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 Close that bracket. And we have another bracket here. Now we solve for what's in the bracket first. So we have true and false, or false is
False.
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 Now we can solve for this. True and false is
False.
False.
false. So we come to the answer.
The answer is true
Is it?
because
The not.
Oh, no.
not.
Yeah, the
Yes,
not.
yes. Yes, I forgot about the not. Yep. Yep, there's a bracket, there's a not. You're right. Now, we have the not, false. Then the answer is true. Question?
No.
No.
No? Easy?
No. Yes.
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 See? You just have to pay attention to the characters. If you're good at that, then you're good to go. Evaluate. Okay, we can see two answers here. Right, well, have a look at the first one. 2 is greater than or equal to 3 is false. 6 is less than or equal to 8. Hey, what a mistake. 6 is of course less than 8.
Yes.
Okay?
Salah tengok je.
Okay, 6 is of course less than 8. So from there, everything will go downhill. Because when you get that false, that statement will yield false and the rest will be false. Well, false as in to say wrong. Yeah, wrong. So let's have a look at this. 2 is greater than or equal to 3 is false. 6 is less than or equal to 8 is true. Work on this one. 2 equal to 2 is true. 3 is greater than 4 is false. So we have 8 equal to 8 is true. From here, we perform everything within the parentheses. False or true is true. True and false is false. Next, we perform here. We perform this bit. False and true is false. This is where this is wrong. Yeah, this is where this is wrong because true, you cannot perform or first. You have to perform and first. Okay, man.
All right.
Right. So in this, as much as the answer is true, but this is where you get it wrong. And I'm not saying just to Aiman because I want everyone to be aware of the situation. So right here, we have a complete statement. We have to perform the order of precedence. And or, and will take precedence over or. So we perform and first, false and true become false here. So true or false become true. Of course, the final answer is true, but the how you solve it is can be improved. Question?
Sir,
Hmm.
how you want to know true and false? That's true. I confused.
Can you see?
Yes.
Okay.
Here and false and true. Yep. No, false is true and false and true is false. So we have true and false. The answer is false. Yes, this is correct. Easy peasy. Any question, by the way? Any question?
No.
No.
No?
No.
Okay. One, two, three, four, 5, 6, 7. Can we work? Can we continue on one-way selection? And we'll stop
Yes.
after
Yes.
one-way selection.
Yes.
Yes.
We'll continue with one-way selection and we'll stop after one-way selection. We are not going to go into compound statement. We'll stop until here. So let's have a look at the control structure. Now, control structure. What is a control structure? You use the selection control structure or decision control structure when you want the program to make a decision or comparison and then select one of two paths, depending on the results of that decision or comparison. So what is the symbol that you can represent in your diagram?
What?
What is the symbol that you can represent this in your diagram?
The diamond.
Yep, there you go. It's the diamond. When you come for a decision or selection, you perform or you represent that using diamond. And diamond generally will have two. One is if the answer is true, and the other is if the answer is false. Suppose that it's coming from here, depending on the situation. What happens if it is true? What happens if it is false? So you use that. Example, if it is raining, wear a raincoat. Bring an umbrella. If it's not raining, then don't do that. Example 2. If you have a test tomorrow, what do? You study tonight. Else, you can watch a movie. So in this case, for example 1, merely to test if it is raining. If it's not raining, it's not part of it. I don't want to know. I don't care. It's not of the part of the program. But here, it will consider both situations. If you have a test tomorrow, you study tonight. If you do not have a test tomorrow, you watch a movie tonight. Okay.
All right.
Here, this example. Here, it will test if it's just raining. If it's not raining, then it's not part of it. I don't care. When I say I don't care, meaning to say the program don't care. All right? When I say I don't care, meaning that the program doesn't care. Only when it's raining, only the program will get involved. If it's not raining, then it doesn't matter. Here, it's the other case. If you have a test tomorrow, the program will say, study tonight. If it's not, then you have to do something else. Yeah? You get the picture?
Yes.
Yes.
So, selection control structure, we have one-way selection, two-way selection, and multiple selection. Only that today, we are going to cover only this bit. We'll save the rest for the other classes. Don't worry, we will cover them as well. The syntax of one-way selection is we use the if statement. Yeah, we want to select. We use the if statement. If expression statement. And that expression is generally executed when it is true. The statement is executed if the value of the expression is true. The statement is bypassed if the value is false. So if the expression yields the result false, it will not execute the statement. It will skip. Boolean expression in the if condition. If quantity is less than 50. Yeah, this is an example. If quantity is less than 50. If it's more than, no, if it's equal to or more than 50, then it won't execute whatever comes after. If age is greater than or equal to 25, so will you be excluded? No, sorry, will you be included? If age is greater than or equal to 25, will you be included? You?
No.
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 No. So that's how it is. That's how it is. If you see this statement, if age is greater than or equal to 25, and you compare your age, whether you are 25 or not, and you realize that you are not 25, you're still less than 25. So this statement is not meant for you. Okay? If on hand equal target. So we compare whether what we have on hand equal to the number that we have in the target. Now, if they are equal, then the answer will be true. Then the following statement will be executed. Otherwise, it will be skipped. If quantity not equal to 7,500, so the same thing, yeah? Any question on this part? No?
No.
It's fairly easy because we simply compare using if. If expression, then statement, and if. Now, in the pseudocode, you have to have the opening if and you have to have the closing if. They must go together. They must go together. In C++, you are not required to have the and if, but in pseudocode, you must have the and if. So for the flow chart, we have the diamond. It doesn't matter where do you put your true or false. This can be false, this can be true. But if this is true, this has to be false, depending on the situation. But what's more important is the diamond. This is the symbol for decision, yeah, for selection. Problem statement. If the speed of a car is greater than 80 km an hour, then output a message, you are too fast. So what's the keyword? We have the speed. Greater than 80 km an hour. Only we output, you are too fast. Begin. Input speed, because speed is the one operator. If speed is greater than 80, now 80, then output you are too fast. When you have if, you close the end if and you end the program. If you enter speed of 50, what will it do?
It will do nothing.
It will do nothing. It will it will terminate the program just as it is. Correct?
Yes.
Yeah. It will end the program. Start input speed. Speed greater than 80. True, you are too fast. False, end the program. Nothing. Okay. That's how you would represent that in C++ program. Yeah, that's how you would represent that in your C++ program. Exercise 1. What is the exercise? What is the question? There's only an answer.
Yeah, it's only an answer.
Hmm. So that's fine. So how about if you modify this to include that if user gets more than 100, you tell you see out cheater.
Cheater. All right.
Yes, because there's no way that you can get more than 100.
Yeah.
Yeah, but if the user gets below 50, you simply see out fail. Of course, this statement has to be there as well. Yeah, if greater than or equal to 50, see out pass. If user put in more than 100, you display cheater. If user put less than 50, then you see out fail. Can you modify that, please?
Yes. Put else if at the bottom.
Come again?
Put else if at the bottom.
Entirely up to you how you want to do that. So I want you to code using the compiler, dev C++.
Oh. All right.
Okay? Are we done?
Yes.
What about the rest of the class? Are we done?
Yes.
Can we ask someone to show the program, please?
Yes.
No, no. Hold on, man. Can we ask somebody else first? Can we ask? Alif Najmi.
Yes, sir.
Yes. Can we see how did you do it?
I tengah buat tengok.
All right.
Dah, sir.
Hmm.
Jadi 2.
Hmm. Okay. That's fine. We'll have a look at why. Did you get that? So can we ask Aiman to show the work, please? Thank you.
Okay.
Yes.
Yes. Could you please show your program?
All right.
Oh. Okay.
Okay. Now, class. This is slightly more advanced than what we've covered today. Only that earlier I mentioned to you, if hold on, let me see. Earlier I mentioned to you, if it is raining, you will do something. But if you have a test tomorrow, you study tonight. else you watch a movie. So when you have else, you combine the two decisions into one decision table. So in this case, we have multiple selection in this. Yeah, this is what we call multiple selection. The one that I mentioned to you that we're not going to cover today. But we've covered this part. If mark is greater than or equal to 50, well, okay. This is, personally, I find this to be a little advanced. Or this is how your code should be typed, basically. Unfortunately, for the rest of you, we have not covered all of this. So what Aiman is doing now is to tell you how the code is supposed to be coded. I'll show you my version for now. Yeah, I'll show you my version. This is slightly, what should I say, a bit too advanced before we've covered everything. So Aiman, thank you very much. Let me
All right.
try to show you my version of that. Merely to answer the question. Merely to answer the question. So I have if mark is greater than 100, see out cheater. Else, now, when we come to else, I perform yet another comparison. If mark is greater than 50, I see out pass. So, who was that earlier that presented? I forgot the name. Was it Alif Najmi, wasn't it?
Yes, yes, sir.
Yeah. So Alif Najmi, this is where it is important. If mark is greater than 100, it will perform this. If it is not, then it will look up for else. Then only it considers it to be within this particular if, within this if statement. So if you do not include the else, it will treat this as two separate comparison. Okay, it will treat as two separate comparison that has got nothing to do with one another. And that's the reason why you get cheater and pass together. Understand?
Yes, sir.
So if you do not want that to happen, you have to include the word else. Now, after else, we perform another comparison and we see out else. This is when there is no other comparison to perform. You see out failed. So even if the user enters minus 50, he will still be considered as failed. Any further question?
No.
Class? No?
No.
No question. We are going to dismiss the class for now, and I will see you again on Wednesday. So thank you very much and Assalamualaikum.
Thank you.